In question 8, we have been given this trigonometric function and we're asked to give it in the form y equals p sine qx plus r. So hopefully we should remember what each of these components does. P here, this is going to determine the amplitude of the function. This component of x here, q, is related to the period. So if you remember the general formula, the period is equal to 2 pi over b. And the final component is this variable here, r, which determines the principal axis or the centre line. So if we write here, centre line. So how do we try and use all the information in the graph to get it in that form? Well, let's start off with the easier ones, which, as they've asked us here, is p. So p is the amplitude. To find the amplitude, the two ways you can think about it. The first one is half of the distance between the maximum and the minimum points here. So the distance between the maximum and minimum is 1, so the amplitude is half of that, which is just going to be a half. The other way you can think about it is find the principal axis or the centre line, which is here, and then it's just the difference from the centre line to either a maximum or a minimum, which clearly is also going to be a half. R then is the centre line. Well, we can see we've already looked at the centre line here. Normally on your standard trigonometric function, the principal axis or the centre line goes through the line y equals 0, but we can see here it's moved up by 1.5, so the centre line is now 1.5, which means that r is going to be 1.5. The final part then, again, we're relating to this formula here, so the period is going to equal 2 pi over b. Now, we've got a different letter here, q, which is what we're trying to find. So if I just rearrange that, we can see that q is going to be equal to 2 pi over the period, which begs the question, what is the period? The period is from the corresponding point. So if we have a look at this point here, we're at the intersection of the function and the centre line, we're going to follow it through one cycle until we get up to here. Now, we can see it's very difficult to ascertain what this value is here. So another way we can actually do it is just to take the distance between a maximum point and a minimum point. Now, because we've got the x-coordinates here, we can calculate that, and then just recognise that this distance here is half of the wavelength. So if we find this blue distance here and double it, we'll also get the same period. So what is this distance here? Well, it's going to be the value of b here, which is pi by 2, minus the value of a here, which is pi by 6. So that's going to give us 3 pi by 6 minus pi by 6, which is going to give us 2 pi by 6, or pi by 3. So this blue distance here is pi by 3. So therefore the entire period is going to be double that, which is going to be 2 pi by 3. So we're going to say q is equal to 2 pi divided by the period, which is 2 pi by 3. That is going to give us, that's going to simplify to give us 3. So the value of q is going to be 3.